નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study about the quadratic polynomials from sum and product of zeros. This is the topic of standard 10, chapter number 2, polynomials. Right? So, in previous class, we have studied about the relation between the zero and the polynomials. And we know now that if we add the zero of the quadratic polynomial, we get the relation with the coefficients. Also, we do the product between the two zeros of the quadratic polynomial. It again is related to the coefficients of the quadratic polynomial. So here we have to do such type of process, but we have to think in the total different way. Here we have given the addition and the multiplication of the zeros. That means the sum of the zero and the product of the zero. These two things we have given. So the sum of the zeros is 1 upon 4 and the product of the zeros is minus 1. These two things we have given. And from these two things we have to find out the quadratic polynomials. Right? So to do that, first of all, we know that the standard form of the quadratic polynomial is f of x is equals to ax square plus bx plus c. Here we can also take the p of x, right? Because it is the polynomial with the variable x. We can define it as f of x or p of x, right? So standard form is this. Now we know that what is the addition of the zeros that we have defined in previous class. The addition of the zero is equals to minus b upon a, and the product of the zero is equals to c upon a, right? So now putting the value of addition of the zeros, that is 1 upon 4, here we get minus b upon a as it is. Now this side also alpha into beta is minus 1, that is equals to c upon a. Now what will happen if we compare the values? See, if we compare this value, minus b we get is equals to 1 and a is equals to 4. Here what will happen if we compare? There is no denominator, only minus 1 is there. So we can guess that denominator is 1. So c is equals to 1 and a is equals, c is equals to minus 1 and a is equals to 1. That is the value we are getting here. So here we get a is equals to 1 and here a is equals to 4. Is it possible that a has two values? This x square coefficient a has two values? No, it is not possible. So now what we have to do? We have to make both these a values equal. To do that, here we get a is equals to 4 and here we get a is equals to 1. So the LCM of 1 and 4 is 4. So we have to make both a value is equals to 4. So here there is 4 is already there. So to make here denominator 4, we have to multiply minus 1 with 4 and 4 in both the numerator and the denominator. Okay. Here also there is a minus sign before b, but here there is no minus sign before 1. 1 is plus, right? So now what we have to do? We have to put two minus signs. Minus of minus 1. We are not actually changing the value of this one because minus minus becomes plus. We are just representing this one in the another form. So here this becomes minus of minus 1 upon 4, right? And this side, these values is also becomes minus 1 into 4, that is minus 4 upon 4. Now we will comparing, by comparing the values, what we will get? A is 4c. Now in both the cases a is 4. What is the value of b will get here is b. Just we have not considered this minus sign, just we have to consider. So this minus sign remains as it is. As a b there is a minus 1. So the value of b is equals to minus 1. And now comparing the c, what we will get? 4 ones are minus 4, that is c is equals to minus 4. Now put all this value of a, b, c in the standard form. We will get the polynomial as f of x is equals to 4x square minus x minus 4. Right? So this is the one of the required polynomial that we have asked in this question. But there are also more polynomials that have to satisfy this condition. And what are that polynomials? See, this is the another kind of polynomials. F of x is equals to k 4x square minus x minus 4. This k is in the multiplication of this whole polynomial. And what is k is? K is the real number. Right? So, in this way, we can find out the quadratic polynomial from sum and product of the zeros. Okay? Okay, let us understand one more example. Here, the sum of the zeros alpha plus beta, that is root 2, is given, and the product of 0, that is alpha into beta, is 1 upon 3 is given. Again, we have to find out the polynomials which has the sum of the product is this and sum of the zeros is this and product of 0 is this value. So again we will know that alpha plus beta is equals to minus b upon a. So here we will compare it with root 2. But there is no denominator, so we can write down it as 1. And the product of 0 is c upon a, and c upon a is 1 upon 3. Now what will happen if we compare the values? Here we will get a is equals to 3, and here we will get a is equals to 1. So now we know that to make both the values of a must be equal. So to do that, we have to take the LCM of 3 and 1, and LCM of 3 and 1 is 3. So here there is 3 is already there. To make here 3, we have to multiply this value with 3 upon 3. Right? Also, now we know that there must be a minus sign, but there is no minus sign here. So we can write down it as minus of minus root 2, because minus minus becomes plus. So we are not actually changing this whole value, we are just representing this value in another form. Right? So now what will happen here? This value is now becomes minus is outside, in the bracket we will get 3 root 2 and the denominator 3 ones are 3. Right? Now by comparing the values, we will get a is equals to 3. See here, both the side, a is 3 and here also a is 3. What is the value of b we will get here is b is equals to minus 2 root 3 and c we will get is 1. So now putting the value, we will get p of x is equals to 3x square minus 2 root 3x plus 1. So this is the required polynomial for which these two conditions satisfy. So there is also another this kind of polynomials which can satisfy these two conditions. And what are they polynomials? They are this p of x is equals to k in the bracket 3x square minus 2 root 3x plus 1. What is k again is? K is the real number. To find out the polynomial, there is another method. See, required polynomial we can write down is p of x is equals to k in the bracket x square minus alpha plus beta x plus alpha into beta. So in this way, by putting the value of sum of the zeros here and product of the zeros here, we can find out the required polynomial. So by putting this value, we will get p of x is equals to k x square minus, now what is the alpha plus beta is? Root 2. Root 2 into x plus alpha into beta is 1 upon 3. Now by taking the 3 as LCM, what we will get? Here both the terms we have to multiply with 3. So this term becomes 3x square, this will become minus 3 root 2x, and here 1 will remain as it is. In the denominator we will get 3, and by taking this 3 to the outside, we will get here k upon 3. So this is the required polynomial. What is k upon 3? Again k upon 3 is one of the real number. So you can see that both these equations, both these polynomials are equal. So you can use either this method or this method to find out the polynomial from the addition and the product of the zeros, right? So this is all about this lecture. Okay, thank you. Thank you for joining us.